All right, let's talk about one of the biggest challenges for anyone trying to break into software engineering, the dreaded technical interview. We're going to crack the code on how to beat it. So you open up Leak Code, right? And you're just hit with this wall of problems, hundreds, even thousands of them. It feels impossible, like you're supposed to climb this massive mountain with no gear. Well, here's the thing, you're not alone. And the path to the top is way, way shorter than you think. The magic number isn't 1,000 or even 100. It's 20. That's it. If you can truly understand and master just 20 specific, carefully chosen problems, you'll have the keys to unlock almost any interview question they throw at you. And this is the absolute secret sauce. Stop trying to memorize hundreds of random solutions. That's a losing game. The real win comes from deeply understanding the underlying patterns. It's all about quality, not quantity. Once you see these patterns, you can solve problems you've never even laid eyes on before. Okay, so let's pop the hood and take a look at these core patterns. Think of these as the essential tools in your problem-solving toolbox. First up, two of my favorites, sliding window and two pointers. These are your absolute power tools for efficiency. Whenever you're dealing with a sequence, like an array or a string, these patterns let you just glide through the data in a single, beautiful pass. And here are two perfect examples. For longest substring, you imagine a window that expands from the left. As soon as you hit a repeating character, you shrink the window from the left until the repeat is gone. For 3-sum, it's brilliant. You sort the array, pick one number, and then use two pointers, one at the start, one at the end, to hunt for the other two. It takes a problem that could be painfully slow and makes it super fast. And here's that two-pointer dance broken down. It's just so elegant, right? You start your pointers at opposite ends of a sorted list, you check if their sum is too high or too low, and then you just nudge one of the pointers inward. You just keep doing that until they meet in the middle. No nested loops, no brute force mess, just clean, efficient logic. All right, our next pattern is basically a superpower. Hash maps, or you might know them as dictionaries in Python. If you ever need to count things, group things, or just look something up instantly, this is your go-to tool. They are a total game changer. Just look at group anagrams. The big aha moment here is that anagrams are just the same letters scrambled. So you can create a unique signature, like a sorted version of the word, and use that as the key in your hash map. Bam! All anagrams get grouped together automatically. And for top K frequent, you first use a hash map to just count everything up. Then you can use another cool tool like a heap to pluck out the most frequent ones. The hash map does all the initial hard work. Now, not every problem is a simple straight line. Sometimes data is all interconnected, like a social network, a subway map, or a web of dependencies. When you see a problem like that, your brain should immediately just light up and scream, graphs. And to explore them, we use our trusty traversal sidekicks, DFS and BFS. For instance, in Number of Islands, you're scanning a 2D grid. The moment you hit a piece of land, you launch a search, a DFS or a BFS, to explore and sync that entire island so you don't count it again. Then you move on. For course schedule, you're checking if you can actually finish all your classes. You build a graph of prerequisites and then look for a cycle. Because if there's a cycle, well, you can't take class A before B and B before A. It's impossible. And that course schedule problem brings up this fancy-sounding concept, topological sort. Don't let the name scare you. All it is a to-do list for things that have dependencies. It puts everything in an order that actually works. You have to take Calc 1 before Calc 2, right? A topological sort figures that out for you. And the key thing to remember is it only works if there are no cycles, what we call a directed acyclic graph, or a DAG. Okay, so you've got the patterns down. That's huge. But that's only half the battle. The other half is learning to think like an engineer. It's about seeing the trade-offs, understanding performance, and spotting those little traps before you fall into them. Now this is super important because we need to bust some common myths. A lot of people hear dynamic programming and immediately think they need a giant 2D grid. But the truth is, a lot of the time, you can optimize that down to a simple 1D array or even just a few variables. And hash maps? We love saying they're O1, constant time, but that's the average case. A good interviewer is going to ask, what about the worst case? You need to know that answer. You can think of this as your performance cheat sheet. When you see a problem that fits the sliding window pattern, your goal should be O of n. If you have to sort things first, you're probably looking at O of n log n. For graphs, it's about the number of vertices and edges. Knowing these benchmarks helps you gut check your own solutions and know if you're on the right track. So we've walked through the patterns, we've talked about the engineering mindset. Let's zoom out and put this all together. What is this list of 20 problems really?
Because I want to be really clear, this is so much more than just a checklist you grind through.
It's a curriculum. It's a masterclass in the foundational, timeless tools of our entire field. These algorithms weren't invented for interviews. They were created by pioneers decades ago to solve fundamental problems in computer science. When you master these problems, you're not just learning to pass an interview, you're learning the craft. So think of this list as your map, a map to a treasure trove of understanding. Each problem is a landmark that teaches you something profound. You have the map in your hands, so the only question left is, which territory are you going to explore first?